Okay. Now, so the next component what I'm going to be discussing is called as what? NAT. Often it is also known as what? Address translation. Okay, so network address translation. Normally, we used to do for private to public address translation. So we know that what is the use of a private IP address, and so when you're trying to access the internet, you have to have a public IP address. Only then the return traffic would be possible. So we normally take the help of this network address translation. When the packet is going out, the private IP address of your internal network gets translated to the public IP address so that the return traffic can come back to the NAT device. Because the NAT device is going to maintain a table, so it can easily track down the received reply is meant for which of the internal host. That is one of the use case. It is also possible that if you have your internal server that needs to be accessed from the external world, what you normally do, you will be mapping a single public IP address to the private IP address, using which the request can be received for that particular public IP address can be forwarded to the internal server IP addresses. So typically NAT is being used for what? You can allow the internal private IP addresses to access the external services, or you have your internal service that could be accessed from your public network. And you also take the help of this NAT for some security purposes also, to secure your internal information also. So I told you that there are three categories of attacks. What are all they? Reconnaissance, access, and DOS attack. I asked you a question. If you are given a chance, which category of attack you will be fighting against first? So reconnaissance is the most important attack. If you can start fighting against the reconnaissance, and then the access and DOS attacks can be prevented. That means until unless the attacker doesn't aware where the actual information is residing, what is the IP address of the server, what operating system which is running over there, he wouldn't be able to proceed with access or DOS attack, right? So by doing this NAT, network address translation, you are hiding those information. So why I'm trying to say this one? Because the NAT is not only from private to public. You have all the choices, private to public. You can do the translation from private to private. You can do translation from public to private. You can also do the translation public to public. All these are possible, right? So assume that you have your internal server which has a public IP address. You still do the translation with a different public IP address, so that your internal actual server IP address is not known to the external world. So they wouldn't be able to launch an attack until unless they track down the real IP address of the server. I hope you understand my point. So NAT is for providing the services. NAT is also being used as a security feature. Okay, so in checkpoint, two types of address translation. One, we call it as hide mode NAT, and the other one we call it as static NAT. Right, so hide mode NAT and static NAT. These are the two types of NATs which are available in such checkpoint. Now my point is, what is hide NAT and what is static NAT? Hide NAT, you can call it as a PAT or NAPT, network address port translation. Static NAT is a one-to-one translation. Okay, now typically the NAT is also being categorized as what? Unidirectional and bidirectional. When I say unidirectional, the request always needs to be initiated from a specific direction. Okay. If I say the source NAT, always the source address is going to be translated if the conditions are met. So the request is being identified on a specific direction. If someone else is trying to request from the other direction, that wouldn't be possible. Say for example, I have a gateway. So I have my internal network, which are in, let's say 172.16.1.0/24. So let's take our own network. So I have my internal network 10.1.50.0/24. I also have my external network or the public network internet. I have a connectivity. My internal interface has an IP address of 10.1.50.1. My external interface has, let's assume that 2.2.2.2. That's my external interface. When it comes to the unidirectional NAT, the type of NAT what I have taken is source NAT. In that source NAT, I said if the traffic is coming from 10.1.50.0/24, translate them with an IP address of your egress interface, which is 2.2.2.2. That's a possibility of this. So what is that happening? I have given this information to the gateway as what? If at all you receive a packet on any of the interface with the IP address on the source field is 10.1.50.0/24 network, then do the translation. So if the request is coming from your internal network where you have an IP address of what? 10.1.50.0, the packets are being received and the condition is met because the source address is 10.1.50.0, and when the packet is going out on the external network, it can be translated to 2.2.2.2 and you can start receiving the traffic as a reply. That will also be permitted. But the problem is, because I have done this translation, if someone else is sending the traffic from the external world to 2.2.2.2, it will never be accepted. That's the reason it is being called as my unidirectional NAT. There is also another example. Assume that you have a server, which is having an IP address as 10.1.50.10. Now you would like to perform address translation 10.1.51.1. That's the IP address I have on this interface, right? I can also do something called as what? Destination NAT. When I do destination NAT, so I'm just going to be identifying some specific traffic. Okay, let me take a different IP address altogether. I'm going to take a virtual IP address as 2.2.2.3. So that's the virtual IP address. I'm going to be mapping it to 10.1.50.10. Okay, so 10.1.50.1. So what I'm trying to do, this is the NAT rule I have created as a destination NAT. If the traffic is going to be received on any of the interface to that 2.2.2.3, which can be translated to 10.1.50.10. So the 10.1.50.10 is my real server where the request could be forwarded out. In this scenario, we are expecting the traffic from the external world to 2.2.2.3. Right? Now, in any of the cases, if my internal server is going to be sending the traffic to the external world, I mean initiating a request to the external world, none of these conditions are met. The traffic is not coming from 10.1.50.0 or the traffic is not meant for 2.2.2.3. Since the NAT rules are not matching, if a policy permits the traffic could be forwarded out. Hope my point is clear. The source NAT and destination NAT are unidirectional NAT. That means the request has to be initiated on a specific direction. Whereas the bidirectional NAT, we have an example of static NAT. What is this bidirectional NAT or static NAT? The moment you do this one, now the same example we are doing it, 2.2.2.3 is mapped to 10.1.50.10. In other way, 10.1.50.10 is mapped to 2.2.2.3. So, if the request is being initiated from the external world and given to 2.2.2.3, it gets translated to 10.1.50.10 and the reply packet will go back. It's not a problem at all. Whereas, there is a possibility that the request may also be initiated from 10.1.50.10 when the packet is being received on any of this interface. Since it is a bidirectional NAT, if the source address is 10.1.50.10, if the source address of the request packet is 10.1.50.10, it gets translated to 2.2.2.3. Is this possible? So static NAT is bidirectional. You also have some unidirectional NATs like source NAT and destination NAT. Until unless it is really required, don't ever go for bidirectional NAT. So if your servers are not at all going to be initiating requests to the external world, you don't need to go for a static NAT at all. Right? You can simply do it with a destination NAT. So you have unidirectional NAT, you have bidirectional NAT. Unidirectional NAT are very specific to the direction and very specific to the type of NAT that you are performing. Whereas bidirectional NAT, the NAT could be performed on either direction. That means the request can be initiated on either of the direction. The reply packets anyway it is going to be coming up. So depending on the direction the request is being generated or received, either the source NAT can be performed or the destination could also be performed. Okay, so that's the kind of a NAT. Now in checkpoint, when it comes to the configuration, the NAT configuration, you have two types. One is automatic NAT, the other one is manual NAT. So automatic NAT are also called as object NAT. Right? So automatic NAT is very simple to configure, but it is not that much granular. You cannot take control on this NAT rule configuration. Whereas manual NAT, little bit complexity is there, but you can manipulate or you can do whatever the type of condition you would like to. So manual NAT is more granular, but little bit complex to configure. Automatic NAT, simple to configure, but it is not much of granular. It doesn't matter whether you have a NAT rule is configured or not. Until unless you have a policy, the traffic is not at all going to be permitted to forward. So your policy, security policy is going to be is meant for allowing the traffic, whereas the NAT is only for doing the translation. So just because you have a NAT rule, it doesn't mean that always the packet will be permitted. You also need to look into the security policy whether that traffic is going to be permitted or not. Right? Let me show you how this NAT is going to be performed. Okay. So I'm just going to be getting into the smart dashboard. Okay. Now I have these objects, right? So automatic NAT is also known as what? Object NAT. If you have this network object, all you have to do is click on the object, right click, then say edit, and then you have a NAT tab. Select this NAT tab, and if you can see this one, add automatic address translation rules. As I have start clicking this one, and what type of NAT you would like to be performing it. If you would like to go for hide NAT, which is nothing but your path, I can say that what IP address you would like to be using it. I have the choice of saying what hide behind gateway, or I also have the choice of hide behind an IP address. When I say hide behind gateway, whatever the IP address on the egress interface, that will be used for translation. So that's what the example I have shown you in my paint. So when I say hide behind gateway, I said that one, if the traffic is coming from the source of 10.1.50.0, my hide behind gateway option is what? It is 2.2.2.2. When the traffic is being forwarded out, the source address is going to be translated to 2.2.2.2. So hide behind gateway is an option with which the NAT will be performed with the egress interface IP address. So because of that, when attacker or anyone who is receiving the packet, they can see the source IP address as the gateway's IP address. It is quite possible they could also launch an attack against it. So if you don't want to reveal your checkpoint external interface IP address with anyone, you can go and select the option as a hide behind IP address, which could be different. So I can go for hide behind gateway. When I select this option, the egress interface IP address will be used for the translation, and that will reveal the gateway's external interface IP address to the general public. Instead, you can have a different IP address if at all you would like to hide your gateway's external interface IP address with anyone. Now, in either cases, let me go there. I have a separate section called as NAT where I can see the rules. Okay, now, since I have created some NAT rules over there, let me go and uncheck this one. So those rules are going to be cleared automatically. If you see it. Okay, so as I have the object NATs, if I go and create a NAT, okay, NAT section, I'm going there, add automatic translation rule and hide mode NAT, hide behind gateway. When I say okay, the respective rules are going to be created automatically. So depending on the configuration of your NAT tab. These are all called as what? Automatic NAT rule. Why they are called as automatic NAT? Because the rules are being created automatically based on the object's configuration. So inside the object, I have a tab called as NAT where I have selected this option. So the rules are going to be created automatically. It is also like your policy, the rules are going to be processed from top down. Okay. So now the point is when I have configured the NAT, I'm seeing that two rules are getting created. And there is also an option of what? There are two sections in this. One is the original packet section. The other is the translated packet section. Original packet section is used to match the packet on which the translation is going to be performed. Translated packet section is going to be helping the gateway with what the translation is going to be performed. Now, I said the original packet, because of the automatic NAT rule, I have two rules that's been created. It identifies the source IP address as admin PCA. The destination is going to be admin PCA. That means if the traffic is coming from admin PCA to admin PCA, for any of the services, don't translate the source, don't translate the destination, and don't translate the service. It is going to be the original. How it has been received, the same way it has to be forwarded as well. Whereas, if the traffic is coming from admin PCA to anywhere else, if it is hitting the gateway, do the translation of the source address field alone. Can you see this H over there? H stands for hide net. Don't translate the destination, don't translate the service. On which gateway it is going to be installed? On all of the gateways it is going to be installed. So the automatic NAT rule is very simple to create. You see that one? I'm going to go there. So automatic NAT, network address translation, hide NAT. That's it, over. Into the host. Let me say like this. I have a network. Let me say net A. This is 10.1.1.0. Net mask is 255.255.255.0. I also have one more network B. Clone it, right? Network B, and then this is going to be network 2.10.1.2.0. Okay. Now I'm creating an object, a group, a simple group which is of net AB, where I'm calling network A, and network B. Assume that I'm performing the NAT for this object. Or else I can create, what is it called? Okay, let me create net AB 10.1.4.10.1.0.0 255.255.252.0. Okay. How many networks are being identified in this? 10.1.0.0 with 255.255.252.0. 4 subnets: 10.1.0.0, 10.1.0.1, sorry, 10.1.0.0, 10.1.1.0, 10.1.2.0, and 10.1.3.0. 4 subnets are being identified with the subnet mask of 252.0. Am I right? Okay. Now I'm going to perform. Okay, name already used, NAT ABC. Now I have this object. Now I'm going to do the NAT for this. When I do this hide NAT, what is that will happen? It will identify all 4 subnet source IP addresses. Let me give an example for you so that it will be easy for you. Okay, this is not good. Let me go to my original. Assume that this is my gateway and which is connected to one layer 3 switch. Let's see like this, and then you have multiple networks connected to it. So this is 10.1.0.0 / 24, 10.1.2.0 / 24, 10.1.3.0 / 24, and 10.1.4.0 / 24. Okay. Assume that they are connected through like this. some 4 interfaces you have, or it could be a sub interface, whatever it might be. They have their respective IP addresses also. 10.1.0.1, 10.1.1.1, 10.1.2.1, as well as 10.1.3.1. Now you would like to allow internet access for these people. When the traffic is going out, it should use the egress interface IP address 2.2.2.2. Correct? Now what I have done, I have created a single object as net ABC with 10.1.0.0 slash 22 is 22. Okay. So because of that, I am identifying 0.0, 1.0, 2.0 as well as 3.0. I think I made a mistake here. This is 10.1. 10.1.1.0 slash 24, 10.1.2.0 slash 24, this is 10.1.3.0 slash 24, and then they are connected to the gateway using an individual interface, or it could be a sub interface, like you do the intervalent routing now. 1.1.0.1, 10.1.1.1, 10.1.2.1, 10.1.3.1. Okay, this is what I have. Now I also connected to internet using my external interface, which has an IP address of 2.2.2.2. I have created an object net ABC 10 with IP segment as what 10.1.0.0 slash 22, which identifies all 4 segments. Instead of doing the NAT for individual subnets, I would like to do a NAT for the component object, the composite object, right? So if it is the case, I'm saying that automatic NAT rule on this particular object said what? 10.1.0.0 slash 22, when it goes out, it should take the egress interface IP address. That's what I have done. But in this case, if the traffic is coming from 10.1.0.0 to 10.1.1.0, the flow is going to be like the traffic is coming here and then hits here and then it goes back to 10.1.1.0. Am I right? In this case, I don't want to perform the NAT. But because of the rule what I have created, if the source is falling in any of this range, the translation will be performed. So when I have created a network object, means the NAT rule, what it would have created, if the traffic is from net ABC to net ABC, no NAT. Are you getting my point? Net ABC to anywhere, do the NAT. So the traffic from any of these segments, the traffic between any of these segments will not be translated, whereas when they go out, they get translated. That is the purpose of those rules are being created.